The broadcast is now starting. All attendees are in listen-only mode.
All right, we'll give everyone a moment to come into the room. Still got people coming in. All right, well, why don't we go ahead and get started? Good morning, everyone. I wanted to welcome you to our first coffee chat session for 2022. We've been using this on behalf of DMSC. We've been using the coffee chats to discuss to the community what a variety of QIF-centric topics. So we're going to start today in this year with, first of all, our session, a couple housekeeping things. First of all, as we go through the session today, you may have questions, and over on the right-hand side of your screen, you'll see where you can type in your questions. You can go ahead and type those in at any time, although we're going to cover questions at the very end of the session. So don't worry if your question isn't answered immediately. When we go into the Q&A session at the end, your questions will show up, and our presenters, Sam and Daniel, will go over those. Again, you can type in those questions at any time. Also, be aware that you will be getting a copy of this video that will come in tomorrow in your email, and also registrants will also get a copy of this presentation. So why don't we go ahead and get started? I'd like to welcome Daniel and Sam. Daniel's with Capvidia and Sam is with Lockheed Martin. So guys, thanks for coming on, and you now have the screens. Thanks.
Thank you, Mark. So I guess I'll get started. If you want to, Daniel, go ahead 2 slides. Sam Gambrell from Lockheed Martin. I'm a quality engineer there, and I will be taking us through the first half of this presentation.
Yeah, and I'm Daniel Campbell. I'm the Vice President of the Model-Based Definition business with Capvidia, and I'll be talking a little bit about some of the, more on the second part, but talking about QIF a little bit as well. So yeah, here's our first part. Sam, you want to take it away?
So the overall presentation, which is probably what I should have started with, it goes over some of the tools made available to everyone through DMSC. So the 3 main tools that we'll be talking about are the Rules Editor, the Resource Editor, and the Data Quality Checker. So for the first part of this, the main focus will be on more of the end user tools, which are the Resources and Rules Editor.
Yeah, so we'll start, I'll just start by giving a little bit of quick background about QIF. I won't spend a lot of time on this because I think that probably most of you are pretty familiar with QIF. But basically, QIF is a data format, an ISO standard data format for specifying quality-related information, especially in the age of model-based definition. This is typically the context that this data is stored, is in the context of the model, in the model-based definition. So we have model-based definition is one of the application areas of QIF. It provides the foundation for storing the CAD data and the PMI. And then we have plans for generating our bill of characteristics, our inspection plan, our control plan, things like that. Resources and rules that we'll be talking about today a lot. DMIS is not part of QIF, but it is harmonized with QIF. And QIF results and statistics for storing, actuals related to your part and being able to store them in the in the context of the model-based definition. So this brings us to our first poll, which is just a simple question. Are you currently using the QIF standard in your workplace? It'll be interesting to kind of see. We've seen over the last few years that the people, the number of people responding yes to this question is increasing quite a bit. So I guess we'll give a couple minutes for people to kind of answer. While that's happening, what I'm going to do next is I'll explain a little bit more about QIF rules and QIF resources, because that's in large part what we'll be talking about for the first part of this talk. Okay, so I guess here are the poll results. So let's see, 40% saying yes, that you're currently using the QIF standard in your workplace. That's cool. Okay, so here a little bit about rules and resources. So the idea of rules is the ability to specify let's say best practices or templates when it comes to how you or your organization would want to carry out certain measurement practices. And these are defined in rules, and then the idea is that the rule would be applied to a part, and you'd come up with a measurement plan based on these rules. And then resources is a way that you can basically specify your inventory of available measurement devices, whether it's CMM or Caliper, gauges, whatever it might be. So that's kind of, it's on those two areas, rules and resources, that this initial part of the talk is going to be focused.
So this is, you can do the full animation, but this is one of my favorite QIF charts in the sense that it shows that the previous wheel we just saw, they all play into each other. They all sort of are more powerful as a collection than as any one individual item. And since we're discussing rules and resources play into QIF planning. So the idea is if you're generating a plan based off of your model-based definition of your features and characteristics, you can leverage the rules and resources to sort of help automate or assist in determining what methods you'll be using to inspect or what strategies you'll be using to inspect. And then on top of that, you can actually then identify the resources or the measurement equipment you have within your facility or surrounding facilities to perform those measurements. So I think on their own, there's value to them, but when combined with the other capabilities of QIF, it becomes even more valuable. So what's nice with resources, and we'll focus on resources before we focus on rules, is it's not just what tools you have, but it also covers the capability of tools. So in this particular example, grabbed a dial caliper and went over some of the items in addition to all the items listed in the top, such as who made it, serialization to identify it, model number, when it can be used, when last calibrated. There's a lot of items that you'd use when determining if and when it can be used, min, distance, max, accuracy, resolution, and what features it can actually measure. And what's nice about this too is this is a simple tool. This is one of the simpler of the devices you can use to measure, and the complexity grows as you get to more complex things, CMM being one of the more complex items. Different methods of calibration, the volume, the XYZ ability to measure, type of probe, star probe, single probes, accuracy of each individual probe, temperature ranges and impact of it. So this hopefully gives a nice overview that it's not just for inventory, it's for capability on top of inventory. So I believe this brings us to our next poll, and the question is, or the poll is, right now, if you have metrology equipment, where is that information currently being stored? We'll give about 30 more seconds until we close the poll. Right. I'm actually surprised to see how diverse it is, how many different locations the information is stored. I'll just keep that up there quickly, but it looks like majority is stored just locally, sort of self-maintained systems, and that there are a decent number within either a calibration or an MES. And for the 4% that aren't currently storing it, I'm very curious how you're managing your quality systems. So there was a very quick follow-up question on that, which we didn't include in the poll, but it's also the fact that in addition to where it's being stored, the question is how much information is currently being stored. And I just know internally with our metrology system, we have a lot of documentation from the equipment OEMs as to what it needs to be calibrated, what it needs to be checked to, which is fantastic for when the parts need to be calibrated, but doesn't work well from a digital thread standpoint. And I think one of the things we're realizing and we're working on is there's a lot of additional information that we want to store, or we want to maintain or keep easily accessible to us, which is not yet in a consumable format. And that's one of those items we are working on with QIF to try to be better at storing the information in such a way that it is digitally accessible. So brings up the question is, what can you do if you have all this additional information? And these are just sort of some ideas of that we brainstormed, and it's certainly not the full extent, but some possibilities are when you get equipment or when you go to the OEM site, instead of having to dig through your spec tables and figure out all the different tables or what web page is this saved in or what PDF, is being able to be provided all the information already in a consumable format by the OEM. So if you're maintaining your own systems, being able to just go and import that information, similar to how some hardware vendors are starting to provide the CAD files. So instead of just a drawing, you can get that CAD file to do work with. Similar idea, if I'm buying a bunch of calipers or gauges, or I'm looking at the different CMMs offered by a vendor, it'd be very nice to be able to just pull in all their capabilities and analyze or just dig through and figure out and filter out what you need or what is capable. Other abilities are too, everyone's storing it different way, local files, calibration systems, MESs. There isn't one master software, master solution that does all the items needed with just build up, inspection, and management of tools. And this would give you a way, other than just the serial number, to be able to pass that information, to manage it in one location, but still leverage that managed information in other systems. The other thing too, on top of that, is any sort of reporting needed to be done, any out of calibration results, or I use the famous word data science in the bottom, is this does give us the ability to more easily query and link together information. So if someone were to do a report or an investigation, and someone has a question of, hey, is this common with all of a certain manufacturer of tooling, or is this current an issue with a certain model number? This gives the easy ability to query that information and to be able to just check that, as opposed to having to sort of dig through and sort of do paper diving. So the other and the last one is the use of rules, which we're going to cover in the next section with the rules editor. So I think there's a lot of capabilities and a lot of doors that are opened by being able to better store your resource information.
So, yeah, so what the DMSC now has available to the public at no cost on our GitHub site is a little simple app for creating and editing QIF resources files, QIF resource instance files. At this point, this particular app is much more sort of narrowly focused than the QIF Rules app that we'll talk about next. It's really focused on CMMs and probing systems for CMMs. So there, right now, it doesn't have support for specifying, like calipers or whatever, any other type of device besides basically just a CMM. But this is actually perhaps a good opportunity for anybody who wants to get into QIF development. This is a fully open source app that's up on GitHub. Maybe it's something that some people would want to contribute to and kind of expand what's possible with this application. Part of the reason that more of the effort was focused on rules rather than resources is because people often have this type of information stored elsewhere. And so this particular app might not be as useful to end users as the rules app that we'll be going over next. But later on in these slides, and you'll be able to access the slide deck as well, you'll find links to where you can get access to this application. So just make sure to download the PDF of this presentation later to get that. So switching gears here a little bit, talking about rules now. Again, the idea of rules is, it's a way of specifying some of the best practices that you want to implement in terms of how you want to go about measuring things. Basically what we're talking about is you have some type of a Boolean condition, if, and then you test some Boolean condition, then you would carry out some action if that condition resolves to true. And so, this might be something, well, here is the list of Boolean conditions that can be checked. What's the tolerance type? What's the value of the tolerance? What is the feature type? Is it a cylinder or is it a plane? Is the feature a datum? Is it an internal feature or an external feature? Different types of sampling categories that you might want to apply to it. And actually, it's pretty flexible. I mean, you can actually go in and start just querying different QIF elements and doing arithmetic comparisons. Like, for example, this is the surface area of this feature greater than 150 or something like that. And then based on how these conditions evaluate, you can carry out certain actions. And these actions mostly correspond to, in the case of coordinate metrology, what your sampling pattern will be. Maybe a minimum number of points or a sampling strategy that you want to take. You can choose the fitting algorithm that will be used for point cloud dimensional metrology. You could choose the fitting algorithm type that should be used for the evaluation. And then finally, kind of at a higher level, you can choose measurement equipment. For example, for this feature, we should use our caliper. For this, for the measurement of this feature, we should use our CMM, things like that. So that's just kind of a quick overview of rules. And here's a real world application. Sam?
All right, so in the screen itself, it may be hard to see. A set of rules and a set of resources were selected, and based off the rule set itself, the preferred measurement equipment was selected for each feature. And to get into even more detail, it is fairly flexible in the sense that you're not just going to say you need to use a CMM or you need to use a caliper. You can get into detail as to saying, hey, these are the preferred methods. Hey, I would prefer you use the CMM, but a caliper and a micrometer are acceptable, but a gauge is not acceptable. So it is more flexible than just saying, hey, use this tool. But it is nice in the sense that it's not just use a CMM. It can say you should use a CMM, and the CMM needs to have this capability and this volume. So it allows you to not just select the method of inspection, but it allows you to get into detail of the specific tools you use to use that method of inspection. So very quickly, we wanted to start off with the idea of what is it you can use rules for other than selecting the right tool for the right job. It's also the ability, if you have a tool that's out for calibration, you can always rerun it and say, what other tools do I have? I'm used to using this tool. I'm used to using the CMM. The CMM is down for a week because we're missing a part. what other tools do I have available to me right now that will meet my requirements. You can also do the fact of if you have a engineer who's coming out with a part and they're getting ready to release it, you can say, let me run this on the part that engineering is in the process of making. Do we have the capability to inspect this part in-house, or are we going to have to go to programs and say, hey, we're going to need to buy new tooling for this. We're going to have to buy new inspection equipment, or engineering. Does the tolerance need to be that tight? We have no way of actually inspecting that tolerance. So it does have a nice fact of not only how are you going to inspect that part, but the ability to take a step back during the design phase and maybe even have some influence of, that's great, you can design this, but we're going to need capital to measure this feature if you need to hold this feature to this tolerance. It also has the ability, if you as a company have certain requirements, or to pass those requirements down to a supplier or a vendor of saying, hey, and we're actually seeing this a lot more now with the idea of profile tolerances and saying, hey, we're trying to design this and we're going to get these parts in, we're going to use the digital twin. How much information do you need to create that digital twin? And this rule set, instead of giving a document to a supplier or a vendor saying, hey, make sure you take X number of points based off of a certain distance when doing a surface, so we can then go and we can remodel it and analyze the part you just produced. You can say, here's a rule set that you can just use to apply our requirements and essentially automate the requirements to a vendor, or a vendor get the requirements from an OEM and automate the requirements for that part. Seeing if I have any other cool use cases for rules other than also checking to see after the fact, if you're concerned about, or if you want to tighten requirements, you can always apply it to previously run cases and see if it would meet your requirements.
And one thing also that might be worth pointing out is that, in case this isn't obvious, but so QIF does not provide what the rules are. That's the job of the end user, is to define what the rules are. QIF rules is a way of encoding those rules so that they could be defined and consumed by software applications. And so those would be the types of rules that Sam was talking about. So the QIF Rules Editor App, Sam, you want to?
All right, so QIF stores everything. QIF is really a method of storing and transferring information. And QIF rules, just like all the other parts of the wheel, is stored in XML. And in the next slide, we're going to show you what that looks like. But it's great for storing. It's great if you're a computer. I don't believe we have any computer attendees. I think they're all people at the moment. As a human, it'll give you a headache if you try to interpret it in its XML state. What the QIF Rules Editor does is it takes the XML and it converts it essentially to a more program-esque or easier, in my opinion, easier to interpret language, so somebody can more easily understand what's happening in the rules and more easily create their own rules. And then when you save it, it converts it back to the XML so that it can, if you want to develop something similar but in a slightly different language, or if you want to import it into a software application to actually be run, it still meets the QIF requirements. I think I have two examples in the next two slides. So this is the 10% rule. The idea is whatever tool you're using to perform the inspection, it needs to be, the resolution needs to be 10% or tighter of what the tolerance itself is. So on the right is how it looks as XML, as a QIF itself, and on the left is when loaded into the editor, the format in that. So it sort of gives you a nice idea that it's a little more interpretable. It can be written out, and it's not something that most people would choose to try to write out by hand. We have a slightly more complicated rule, and in this rule, if you can actually read the top description, or I believe it's fairly interpretable on the bottom left, is for cylinders that are internal and for parts that are under a certain volume, you may use a CMM, which meets certain requirements where the length of the probe is greater than the feature length, where the tip end diameter is less than a third of the feature size, and the Cartesian resolution is less than the tolerance. And then you also have a extra case where you have a specified tool, the Binford 6100 cannot be used in this case. And then demonstrate with this is you can certainly add, your rules can get more and more complex. You can make them as complex as you want, but as you do that, the actual XML output certainly grows pretty quickly. So the idea is with this tool, or any tool anyone would want to make for creation or interpretation of rules, is you don't want to be working with the raw data if you can avoid it. And this tool gives you a much easier way to generate or create your rules and manage your rules.
And so, yeah, a little bit about where you could find these. Again, make sure you download these slides after this presentation. I think they'll be sent out or put up on the website. But there are links to the GitHub site where these can be found. So it's github.com/quality information framework, and you'll find the QIF Rules Editor repository and the QIF Resources Editor repository. They contain, the full source code, a user manual, a general explanation of how to use it, and then instructions on how to build the tool if you want to. But most importantly, you don't have to be compiling any of this yourself. There are compiled executables up on the GitHub sites where you can just download the app and run it right away. Yeah, I mean, for the QIF Rules app, we're definitely looking for feedback. So we'd love to have some users start to use it and get some feedback. And the Resources app, it's maybe still a little immature, and so if you're looking for a project to contribute to, this would possibly be a good one. Yeah, and so we were going to take a few questions now about the Resources and Rules app, and then move on to the second half. So we got one question about what's the maturity of industry software that is able to use QIF rules and able to use QIF resources. Sam, do you want to take a first stab at that?
So I'd say for the actual execution of the rules, it seems that industry is in the process of catching up. And resources too. The resources one is more interesting in the moment because, even as noted in the previous poll, there's already been a drive to manage our resources digitally. I think what we are seeing is that the amount of information attached to each resource is not machine consumable at the moment. So we are in talks with our calibration software vendor to see how can we add more information. I think it's also a change of I don't want to say scope, but right now a lot of the data is tabular. And as we're realizing, you can't just say the accuracy of a caliper is equivalent to the accuracy of a CMM. CMMs, as the part grows, you have a accuracy based off of length, you have an accuracy connected to temperature. So different tools we use have a wide range of capabilities and a wide range of information we'd want to store. So we are sort of trying to figure out that hurdle of, for how we are storing that information, we need the software to be more flexible to store different attributes based off of the equipment it's storing. So that is being worked. What is more interesting or exciting is the fact that while the software is playing catch up to the concept and the ideas of rules and resources, is as we review a lot of our older documentation or just our standards and practices, we've already been creating rules. There's the rule of thumb, the 10% rule that I think most people live to. But on top of that is we do have standards internally, and there are published standards of what tools to use in what situations and what levels of accuracy. And while those do exist, they don't exist digitally. They exist as large PDF documents, and they exist as tabular data of, hey, if the tolerance is within this range, do this. If it's within this range, do that. And I think we see a large opportunity to make it more mathematical instead of sort of trying to limit ourselves and make little bins of what can and can't be used. We may have the ability to really leverage the full capability of our tools and our measurement equipment by leveraging math as opposed to saying, here's your large table. If it's a green square, you can use it. If it's a red square, don't. If it's yellow, contact quality engineering. So hopefully that answered. It's coming. It's not as widespread as I would hope it would be just yet.
Yeah. Let's see. Another question. So are there any size limits for the resource file? The answer is no. I mean, you can create an instance file, a QIF instance file of any size. At some point, you start to have practical limits. Do you want a 3 terabyte XML file? But I guess the main thing to point out would be that QIF has the ability for files to reference each other. So it doesn't necessarily, if you're going to do an MBD workflow where you have a CAD model and you're going to create some planning data and some results data, and you're going to insert rules, or you're going to run rules against that, and you're going to use some resources and everything. That doesn't necessarily need to be in one monolithic file. You can have a QIF MBD file that might reference rules files or resource files that are available on your corporate network somewhere, placed globally, in some globally accessible location. And so you could do external references like that, and that's typically how people will implement QIF.
So I would like to add to that, because there's another question also, how can a resource file be queried SQL? And I think that sort of plays into the idea of what is the size limit. Is QIF doesn't have to be how the information is stored long-term or where it lives. And in the case of our metrology software, I can't imagine them reinventing the whole entire backend of their system to make it stored in QIF. But what I do want from them is I want to be able to either run a report or get information and have it exported as QIF. So if somebody has it in a SQL database or someone has it in a NoSQL database, I want to be able to go to them and say, hey, look, I'm developing a new inspection plan. I don't do my inspection planning in the metrology software. I do it in my MES. I want a report, or I want a snapshot of what are all the tools available to me in this facility that are currently calibrated or are not identified as missing. And I want that provided to me as a QIF document that then in my next piece of software, I can ingest and work with. So I can't imagine a situation with the resources, especially since resources are dynamic. You get new equipment, you get rid of old equipment, you can store calibration data on that equipment. Sometimes you change the accuracy of your equipment if it's starting to trend out, but you still want to use it. So I don't necessarily see people sitting there maintaining larger databases of resources in QIF, but I would like software that's provided to manage my resources to give me the ability to pull that information out as a QIF format.
Well, let's real quick. Let's go through the. We'll go through the second round. We still have some questions. There are some good questions up there, but we'll go through the second portion of this presentation, which will be much quicker. We'll kind of breeze through this, and then get back to a final Q&A at the end, and wrap up like that. So just want to quickly go through a little bit about some of the additional resources or tools, I guess, up on the GitHub site that are useful. But here I want to point out that these tools are especially valuable for software developers. So if you are an end user who is interested in getting involved with QIF and using QIF, it's important to note that you don't need to know anything about what we're going to go over here. You don't have to understand any of this or ever use any of this. This is mostly for software developers. So I'll go through it pretty quickly. Well, our first poll here is, how technically in-depth do you get with QIF files? So we'll bring up that poll. It's just, yeah, I mean, what's your level of comfort with QIF instance files and with the schemas and so forth? Does that poll up? Or there we go. Okay. So it's actually, yeah, it's actually been interesting to see that you know, there are a lot of end users actually that get into doing some level of software development with QIF, even though they are end users, which is interesting. And actually, it's a good thing to see, because when QIF was initially designed, part of the reason that you know, a schema-based XML format was chosen is because the hope was that it would make it very easy for people to jump into, you know, software development, even if it's at a basic level, to be able to sort of, you know, do a quick query of an XML file and pull out, you know, little bits of data, either using some script that you've written or just maybe using XPath or something like that. So we'll give it a couple more seconds, and yep, okay. So here are the results. So yeah, a lot of people not gotten into QIF. Yeah, about a quarter of people are developing some stuff. And then, yeah, I mean, a good almost third of the audience here is fairly comfortable opening a QIF file and looking around in it, which is, yeah, it's interesting. So a little bit about some of these tools. I mean, you know, again, you'll have access to these slides. I'll go over them really quickly. If you care about this, I would recommend getting the slides. And if you wanted to find out more, just shoot me an email and I'd be happy to talk more about it. But so yeah, QIF is an XML-based format. This is a little bit explaining what XML is. The XML, like the format of a QIF instance file is defined by schemas, XSD files, XML schema definition files, which basically defines what is a valid QIF file and what is not a valid QIF file. There's an expected format that the XML data needs to have so that software can read and write, you know, different, this is what makes it a standard. Different software tools can read and write the same data format. And so that's what we use the schema for. And then finally, there's XSLT, Extensible Style Sheet Language Transformations. It's basically a programming language for manipulating XML documents. And QIF provides, as part of the standard, some higher level checks, validation checks that could be run on instance files to make sure that do certain sanity checks on the data to make sure that the data is valid. So how does this apply to QIF? Or how is this useful for QIF? So looking at the schemas, what you can do is if somebody sends you an instance file, a QIF instance file, a .QIF file, you can take that and you can run it against the schemas that are available on the QIF website to validate that it is in fact a valid QIF file, according to the schemas, that it does conform to the schemas. There are some popular tools for doing this: XML Spy, Visual Studio Code, Notepad++ can do it. You know, here's an example of how it could be done with Visual Studio Code, and there's an extension for XML. But there's a chance that you might not have access to these tools, and so we wanted to create an easier way to run a schema check. And so we put a tool up online that allows you to very, very easily do a check of a QIF file against the schemas, and it'll report any improper QIF grammar that's detected, or once it's, or if there are no issues, it'll say XML validation succeeded. So here's a kind of a simple little example of a check that was carried out there. So go online if you want to be able to do checks. Go online and look at this tool, and you'll see more about how that could be run. And then the other tool that's been added to the repository is the checking tool for running the XSLT checks that are provided as part of the QIF standard. And so, you know, these do some checks that are sort of higher level checks than what the schema can govern. But they will, you know, they'll run certain sanity checks to make sure that the data is valid. So an example here would be, you know, when we have our list of datum definitions, we might have 3 datums in our file, And this n number is an integrity check to make sure that n should equal 3. So if n equals 3, we should expect to see 3 datums. So we see 3 datums, but this integrity check value 1234 is not correct. So this is the kind of thing that the XSLT files can check, as an example. And so if we run this this tool on this particular file, we get the report. The number of array elements doesn't correspond to the n value, 1, 2, 3, 4, and the number of elements is actually 3. So if we go in and we fix that, we set it to 3, we'll end up getting a clean XSLT check. So again, this is a tool. The source code for it is available up there, and also a precompiled executable if you want to be able to run the XSLT checks yourself. So in this repository that you'll see up on the GitHub site, there's QIF Validation Tools. Here you'll see these 2 simple command line tools for checking QIF, the Schema Validation Tool and the XSLT tool. And then additionally, there are a set of additional XSLT checks that have been developed, and they're proposed to the DMSC as part of the next version of QIF that will be released in the future. So there are some sort of additional checks that you could take advantage of if you wanted to. And last thing is just one quick word about other resources that are available up on GitHub that could be useful. So if you go to this website, qualityinformationframework.github.io, or again, just download these slides and you'll have the link. There are a few different tools that are up there that are actually pretty useful. I mean, so this schema browser is an HTML-based online browser for looking at the QIF schemas. And so if you want to understand a little bit more about how all the QIF data is organized, you could use that schema browser. We have our validation tools that we talked about, some sample instance files that are up there, the editor app and the resources app that we talked about today, source code bindings for generating your own software application in C++, C#, or Python that could read and write QIF, an issues list where if you want to report some issues that you think you found, or if you wanted to suggest some improvements, you can go there, and then a link to our website. So our last poll question of the day is, what is your level of interest in the QIF tools available on the QIF website? So just trying to get a gauge of, at what, what sort of percentage of our users would be interested in trying to make use of some of these, more deep dive technical sort of tools. So we'll give this poll a couple more seconds for everyone to kind of chime in. And again, the next section that we'll be doing after this is another, just kind of wrapping up Q&A. So we'll try to get through the rest of the questions that were asked here. There are a lot of good questions here. Okay, I think we got our questions in, or our responses in. And so here we have the results. Yeah, actually a good number of the users here are interested in these tools and probably using them. And yeah, a lot of people need to study them, which is good. So, okay, well, very good. So now we'll get back to, just open discussion, general Q&A. If you have questions about anything, either this last section or the original section about resources and rules, please go ahead and type them in. Let's see. So I guess one question that was asked is, is a lot of this new functionality and is is the DMSC working through some of the initial, working with some of the initial users and kind of documenting what are some of the shortcomings encountered with these new capabilities? Are there active working groups or benchmarking groups and so forth? And this is a good question about rules and resources. There is not currently, outside of the main QIF working group that is working on the development of these. There's not currently a working group that's looking into this directly, or that's focusing on this directly, well, specifically on these applications or anything like that. There is a working group that's focusing on resources, especially as it relates to non-contact scanning. There is also a pretty active working group related to, in general, the topic of model-based product characteristics. So sort of high-level control planning as it relates to a model-based definition workflow. Those are the couple really kind of application level working groups that are active right now. And so they touch on some of these areas for sure. But I would say that this particular area of using rules in order to come up, in order to apply resources, especially, it really is pretty new. Not only in terms of QIF, but I think even just in general, that it's kind of a relatively new concept. I mean, as Sam mentioned earlier, often organizations will have sort of PDF specifications that try to specify rules and things like that, but often they're not, totally algorithmic. There might be lots of room for sort of lots of wiggle room to them. Maybe they're not really very uniformly applied or enforced. So it's a big growth area, I would say. And so this is, I don't know. I mean, possibly this is something that the DMSC should start to put a little bit more effort behind.
I see a more general question about the digital thread, and in particular about linking all the way back to the native CAD format. So that is something we are dealing with too at the moment. I believe the answer is persistent IDs. However, I think that's something that industry is still working on, sort of figuring out where do persistent IDs need to be. Do they need to be on everything? Do they need to be on key items? However, so if you ever look through the QIF schema itself, there's a lot of things, particularly parts, features, and characteristics that contain an element called UUID. And the STEP community has sort of done something similar where they're starting to investigate how can they add, I think they're calling it anchors. How do you add anchors to certain items so the information in it is linkable and applicable outside of the particular formats? So once STEP and QIF have sort of solidified where those persistent IDs need to live, then it's sort of our action to then work with the CAD vendors and say, hey, when you do an export or a save as, you have internal IDs within your software, and we need to just make sure that we carry that information, that linkage to these formats, and then allow the CAD companies to say, hey, look, these are the results, this is the information, these are the areas we have difficulty machining or fabricating, and these are the areas we don't, or these are the areas we're constantly writing up discrepancies against, and allow it to feedback. But we do need that lifeline, we do need that link or that persistent ID back to the CAD vendors, and that will hopefully allow us to then generate our thread and generate links between standards and formats, neutral and native, to build that full thread. So you are right, it does not exist at the moment, but I think we have identified what is required to create it.
Yeah, I think the other challenge there is that it's not uncommon that a lot of the CAD and PMI data that's created right now is very non-semantic, and so it makes it that when you try to load that in downstream software, it's not machine readable data, and this can cause a break in the digital thread. I would say that is changing as people are becoming more educated about the CAD tools and how to properly apply PMI, and also why it's important to apply PMI. I think sometimes there used to be the perception that well, as long as it looks good on the screen, that's good enough. But I think people are starting to realize the importance of machine readable PMI data. And so it's starting to change. At the OEM level, they're in control of the data. So usually at pilots done at by OEMs, there's a lot more success with some of those pilots because they'll just go back and make sure to improve the data. It could be difficult for contract suppliers that are not the authors of their own of the data that they're getting, and sometimes they're given bad data to start with, and there's not much that could be done. But it's definitely a challenge. But I think that we've already seen over the last couple of years that this is really starting to get cleaned up quite a bit, and yeah, I think that we're seeing this change pretty rapidly right now. Let's see. So another question about if there are any recommendations at what level different companies should get involved with the DMSC and with using QIF. Sam, did you have any thoughts on that? I guess I have some thoughts.
Just there's shortcomings, opportunity for growth. I know sort of when we were originally playing with it, there were certain situations where there are capabilities or features or items from the part as a whole, such as the mass of the part, or even just the ability to more easily query major and minor features. I kind of like the idea that if you determine that something's critical, maybe you want to be tighter than 10%, or if something's determined minor, maybe the requirement to inspect it, you don't need a tool that accurate. It's preferred, but it's not a hard requirement anymore. So internally at Lockheed Martin, we do have a project going on to figure out, hey, how do we take our documented rules, our PDF files, and what can we gain by making it digital, by allowing us to do math as opposed to referencing tables? And as we do that, there are small things that we are realizing are missing or are not available that we're hoping to get added to QIF 3.1. So what's nice with XML, and what's nice with the format being in the state it's in, is as things are identified, we're looking to add it and expand its capabilities. So it's not that we're in a situation where the rule set is set in stone and we're done, and if you can't do it in QIF, you're not allowed to do it. I think one of our hopes is that people will play with it, use it, and if there's things they don't like about it or things they feel can be done better, that they're vocal about it and that we implement it.
Yeah, I mean, I would say as far as helping to contribute to some of this, I mean, first of all, formally joining the DMSC is a big step, and then getting involved with some of the working groups, I think, is good. It's good, I think, to bring, for all of the different members of the DMSC to bring their own perspectives to the working groups, because every, especially every end user company has kind of a slightly different perspective, a slightly different way of doing things. And, obviously the objective of QIF is to be able to support, a wide range of use cases. So I think, getting involved with some of the working groups and just formally joining the DMSC is probably good ways to get going.
So there's a comment asking about the digital thread, and I assume it sort of reads persistent IDs and how it relates to manufacturing data. So I say there's two things there. There's the if you're machining a final feature and that's already assigned a persistent ID, then if you're sending a signal using MT connect as to the tool being used and this feed and speed, that persistent ID would be the same persistent ID that QIF would then leverage to report the measurement result. If you run into a trickier situation, which I haven't had a chance to tackle yet, about non-final features, such as maybe you're machining a cylinder into it to put a chuck against and to hold that while you're performing another machining operation and you want to track that, I think my general thought or general approach would be, when that feature is first defined, that's when it needs to first get its persistent ID. The sooner on you can give it the persistent ID, the more application it has, the more you can leverage it within the other tool. So I think one of the things I wouldn't want to see is for QIF is that engineering makes the part, manufacturing determines how to build it, then you generate your QIF file, and that's where all your persistent IDs are first created. because then you lose that capability to use it further up in the chain. So when someone's making the CAM software, whatever format, being it STEP AP238 or a proprietary format or whatever format they use, when those features are created, if that information is stored long-term somewhere with a persistent ID on it, then there's no reason that QIF couldn't then generate a feature with the information and that persistent ID to then link to and provide that information so it can be fed back to it. So there's really no reason it can't be a final dimension or an intermediate dimension. Just the general rule of thumb should be is as soon as somebody decides, being it an ME or a designer, that something is needed and it has some sort of requirement to it, at that stage, at that birth of that information, that persistent ID should exist there. And then anything that gets it down the road can then leverage that persistent ID and share the fact that all these different formats or ideas or concepts as they're being talked about are all referencing the same item.
Yep. And yeah, so just I guess a quick reminder. So you'll get the you'll receive a recording or the recording of this webinar. You should have the links to download the PDF. And Mark, if you want to take us home.
Yeah, guys. So thanks very much for the presentation. I hope that our viewers found it very informative, and we're very appreciative of your time to put this program together. So it's the intention of DMSC to have a QIF coffee chat every month, and so our session for next month, and can you put that last slide up, please? Our next month's session is going to be on March 22nd. It'll be at the same time. And Daniel or Sam, can you put that last slide up, please?
Yeah, is it sharing? Ah, there we go.
Right, so here's our next session for March, and we're hopeful that everyone found this session today to be informative, and you know, our future sessions will be equally as informative, and we're grateful for your participation. So we're going to conclude the session today, and again, thank you for our presenters and also for everyone that took their time to attend. You'll look for those videos, links coming in your email tomorrow. And if you have questions, please be sure to contact us and we'll do our best to get you some answers. All right, everyone. Thank you very much.
Thank you.
Thank you, everyone. Thank you for some good questions.